Okay, welcome back. I've been teaching calculus now, going on close to 18 years, and it always amazes me how people think that calculus is this really difficult idea and no one can even fathom it. It's a very simple concept, and I would say most Algebra 1, definitely Algebra 2 students can understand the basic idea of Calculus 1, and that's the concept of a derivative. And that's what we're going to talk about right now here. So, first thing I want you to see is we have a curve here, and I'm not going to call the curve anything except y equals f of x. So what I mean by that is that this is my curve f of x, and let's say right here we have a point. And I don't know what this point is. I'm going to look at it very generically. I'm going to call it just x, comma. Now, most of my students would like to say then y. Well, I'm saying that y is the same as this function x, so I'm going to call this x, comma, f of x. So just think of it this way, that if you plug x into the function, our output is f of x. So right there is we have some point there. Now our goal is to figure out the slope of a tangent line. And what that means, right here is an example of a tangent line. This might be a little difficult to set up at first. A tangent line is a line that comes up and only touches the curve at that one value, at this one point, only once. We call anything where it touches it more than once a secant line. For instance, if I would look at this line here and say, what about this one? This would be a secant line because it's going to be touching the curve in more than one spot. But instead, what I'm looking at is just a tangent line. And we're going to try to figure out the slope of this tangent line, going back to the concept of slope equaling the rise over the run, which is an Algebra 1 concept. But the catch here is there's no run. Run is how far horizontally, how far to the left or right it's moving. And right now there's no distance. So what we're going to do is we're going to cheat for a little bit. I'm going to get rid of this line for a moment. I'm going to put it over there. And instead what I'm going to do is I'm going to add a second point over here. And where a lot of my students want to call this some new value like x2 and stuff like that, what I'm going to do instead is really relate this point to this point. So all I'm saying is I'm going to move over some distance like that. And what I'm going to call this distance is h, the amount I moved over horizontally. So instead of just calling this point x2, I'm going to call this new point x plus h, my initial x plus the h, which makes then my new y value f of x plus h. So now we have 2 points. And I can find the slope between 2 points, again, Algebra 1, quite simply. And that's going to go back to this concept of how much did we rise and how much did we run. So if I look at the slope of that line, it's going to be how much did we rise, which will be the difference between these two values, f of x plus h and f of x. So I'll write it as f of x plus h minus f of x all over the distance between these 2 points, which is x plus h minus x. So when I simplify that up, I end up with f of x plus h minus f of x. We cannot simplify that. However, we can simplify the bottom. We can cross out these x's there. So I'm left with over h. And that's the slope of a line. And here's where calculus comes in. Calculus says, well, what happens if we make h really small? If I make h, let's right now make h only half as big. So I'm going to make it that much further. So that would give us a new value here, which we then could draw a new tangent line, and we get a little bit more accurate as far as the slope of that tangent line. And then if we can go half as big, we can go even smaller. So we'll go half of a half. We'll go a quarter as much. So now I have that line there. So we now have this tangent line. And our goal is to make h so small that eventually it just looks like that. So look what was happening here. As h got smaller and smaller, I'm just going to write it this way. As h gets closer to 0, we see that we can figure out the slope of this red line. Well, that makes it nice. We can just do this then. F of x plus 0, because that's what we want. We want that to be 0, minus f of x over 0. Well, here's our problem, though. We get 0 over 0, and a number over 0 spells no. You can't do it. But that's where calculus comes in. Calculus says, well, don't set it equal. Say it approaches it. So instead, we'll say f of x plus h minus f of x all over h. Now, again, don't forget, that's our slope equation from Algebra 1. But now we're going to say what happens as we get really close to, and I'll say the limit as h gets tiny. So as h gets smaller and smaller, we end up with this, the slope of that red line. So we end up with the slope of the tangent line, which in calculus is called the derivative. And the derivative is probably the most important concept that you learn for the first few chapters in Calc 1. And it's nothing more than this. So I hope this helped. If you have any questions, don't hesitate to call. Keep learning, and good luck.